Okay, today I'm going to show you how I made this fire effect in the oil drum. Cheap and easy, so let's get to it. I've just spent the last 2 hours trying to sort a problem with OBS and recording. I recorded most of this video already, but all the footage is useless. So, lesson learned. I should know better. So, I'm going to do this all again. So today we're going to be playing with some LEDs to create a oil bin fire effect on the model railway. On previous kind of thumbnails you've probably seen the oil drum, and this is how I did it. There's no fancy electronics involved, there's no circuits, no timing circuits. Originally I looked at using a 555 timer. There's plenty of videos online showing you how to use this, but having a look at it, one day I was walking along in my local B&M shop. This is the shop that you go in for one thing and you come out with about 20, and I found these 8 flameless LED candles. So they have a little flickering effect. I shall show you one that I've already taken out, and hopefully on that, if I turn it to the side, you can see it has a little flickering effect. It's supposed to look like a candle. These are the type of things when you've got small children around and you're not using real candles at Halloween and things like that. These are brilliant just to create little effects here and there. So what I'm going to do is I'm going to show you how I use this to light up a little, well, oil drum that is 00 scale, roughly. I've scaled it down. What I made the actual drum out of was some aluminium or aluminum tubing from B&Q. It was like £5 for 10mm diameter and 1 meter long, so I've got plenty, but I'll use a couple of bits to create the oil drums, but I'm sure I'll find a use for the rest of it. So first of all, what I want to do is I want to cut roughly, it is about 13mm in. I will cut that with a hacksaw and then I will come back to you. Okay, this is all cut and all filed down now, so just have a very small cylinder that we can then put our light into. Now, take this apart. We'll use a couple of bits from it. I was saying 8 for £3.50, and you get a battery with it, and you also get the little, I suppose, candle fitting as well. That comes in handy. So we'll open this up, take the battery out, and okay, so we're removing one screw, lifting the battery lid up, the little It's a 2032 3-volt battery that's in that. Need to take the back off this. There's a little docket at the side. You get a screwdriver in and just prise it off. The switch is really basic in this. It's been moulded to fit the pins of the actual LED itself. So the other thing we'll need off this is this little rubber fitting that's supposed to look like a flame. So we've got our little LED. I just want to have a wee quick test of it. One quick easy way to do it is actually take the battery. These batteries are really good for testing LEDs. So on a standard LED, this green one, operating voltage around about 2.5 volts, so 3 volts, so it kind of goes 2.5 to 3 volts. The operating voltage varies between different colours. As I think the blue one it goes up to about 4 volts. But, so apply 3 volts, not for very long. So the longer on a standard LED, the longer pin is the positive, the shorter pin is the negative. That side of the battery is the positive, so if I put these together, the LED comes on. So these are very good. I always have these on my workbench just for testing and making sure an actual LED is working okay. For the flickering LED, now these pins have actually been chopped, so the actual anode, the positive side, is actually shorter on this one. So it's just obviously to make the switch fit properly. And as you can see, when that powers up, potentially it just starts flickering. So I'm going to take this, and I have built a little temporary circuit for this just now. It's a small 5-volt power supply, breadboard, positive rail, negative rail, 220 ohm resistor. The other side of the resistor is connected to the red side of this wire, which is going to be the positive, and the black side is going to be the negative, and then that runs back into the negative rail. So we'll take our little LED and we'll just have a quick test. That'll be positive, negative, and lo and behold, that has come on. On the board, I've installed a lot of these connectors. The one that's underneath the actual oil drum is actually just sticking out of the board, so that I can lift the oil drum off, and if I need to replace the LED. This is one thing I haven't tested. I haven't tested how long these LEDs will run for. Because it's a 5-volt power supply, I have to put a resistor in line just to keep that at its operating voltage, and the resistor does all the hard work. So yep, that is working fine. So the next thing I need to do is create the actual barrel itself. Now, the top of the barrel, you could do different things with this. You could paint it, you could spend a long time painting it, just obviously creating a better effect if you're creative with your painting. At the moment, to save time, I am going to colour this in with a couple of Sharpies. So yep, I'll get this, and I shall colour these in. Colour this in. Obviously it's better to actually paint it. Some Airfix paint or something like that. Just create your own effect. You can add in a rust effect, or you could paint it bright red, but because it's been used for burning wood, it's probably better that you look like it's a bit worn down. Colour in the edge. You've got an option whether you could file the edge down so that it's thinner, but once you put the fabric on, you really don't see that. I'm just going to colour in the inside edge black. Generally, once you've used an oil drum to burn stuff, it's all black inside, so don't need to go crazy with it. And you'll generally get the basic idea. If you're painting it, you can get rid of the actual shine as well. It's just really up to yourself what you want to do. So the next thing is we want to create a holder for the LED, because the LED is this is the base, it's going to come up and sit inside that holder. So this is what we've got, the little bulb effect for. We're just going to chop the top half off, and if we make it kind of big enough to fit into the base. No, needs a wee bit more. You probably, actually, to be honest, if you're using Sharpies to paint it, do that last. I'm just being lazy at the moment, just to generally show you. Next thing you want to do is you want to glue that in place. So, yeah, again, your preference. If you want to, I'm using super glue here, which you'll know I get everywhere if you've watched any of my videos before. Just a wee bit of super glue, stick that in. And you've now got a kind of rubber seal to hold the LED in place, and that'll just go in there. So just let that dry for 2 seconds. Next thing we're going to do is this little bit of fibre. You can get these from, I suppose, what's the word I'm looking for? Textile kind of type shops. You just want to try and scrunch it up, and generally just try and roll it so that you kind of get that flame going up effect. You also can get this, you generally find this kind of fabric in fabric shops, but you can get it in like say pillows and duvets. It's kind of an easy place to find it. What you want to do is you want to stick that in there, and you can additionally add some colour to it if you want. The LED itself is yellow, but if you want to add some just generally different colours, you can just randomly colour it in. I don't really like the red, but you can play about with that. Next thing, if it stops sticking to me, I want to put a wee bit of glue inside, a tiny bit of glue, tiny bit of glue. Problem is with this stuff, it just, of course I buy the cheap stuff, it just wants to come out really fast. And we're sticking that in there. So I hope you can see we have fibres. I mean, you can use the scissors, chop that. So you've got the drum, and this is going to be the flame effect. Right. Next thing, we get our little circuit back and we can test it. I mean, you can just stick a normal yellow LED in it, but it's not going to flicker. But as I said, those ones are found in B&M bargains. They're cheap as chips, and you get all the other wee bits, especially that little rubber seal. So put that into there, and lo and behold, you have a flickering LED light. I will switch this off. I don't know how my camera will handle this. And you can see that creates a nice little fire effect on your model railway, or anything else that you plan to build, like a diorama or anything like that. These just a quick and easy effect to make your basically a burning oil drum. You've got an industrial site or anything like that on your board. There's always work people that need to get warmed up, especially in the winter. You could, as I said before, you can paint it up. You could even put the little barrel lines, the welds that are around there. I think I've done that with the one I've actually got on the board. This will probably go over the other side. There's going to be another industrial site that will create at some point. So I now have two, and the big trick is actually getting power to it. Easy one is obviously just using one of these with a little switch, but obviously the batteries run out. I have a 12 volt bus running underneath not an actual bus, but a power bus run underneath the board. I also have a 5 volt, and I'll take the positive end of the bus, run the cable down to one of the control panels, get a switch, if I can find where the switches are. These are probably ones that I've used. Yep, used the project. Get a switch, and solder that up. Positive end, the way you switch it to the middle, and then take one of the pins and take it out to the positive end of the LED, and then take that, add a resistor depending on your power supply. There are equations to work out what type of resistor you require. I mean, 220 for a 5 volt supply is fine. If you were going for a 12 volt, I would say about 700 to 1k. 1k to be on the safe side, if you had a 12 volt supply. This is a diagram of the basic circuit we'll be using to light the LED with the 12 volt power supply. You've probably seen this diagram a million times. I'm just going to go over this quickly. So in the datasheet for this LED, the working voltage is 2.5 volts and the current rating is 20 milliamps. As you can see, we're using Ohm's law to calculate the resistor value. So we need to find out what the voltage is across the resistor. All we do is take the working voltage of the LED from the voltage of the power supply. 20 milliamps is equal to 0.02 amps. So when we put these values into the equation, we get 475 ohms. When you're buying resistors, resistors will come with a standard set of values. So the closest values to what we require are 470 ohms, 560 or 680. For this circuit, I would use a higher resistor for this circuit for extra protection for the LED. So I would go with a 680 ohm resistor. Okay, as you can see here, if you can see past my noggin, this is a control panel that I built, a combination of potentiometers and switches. Built this to control all the lighting effects on the board. So what I've done is I've used a 12 volt bus, taken the positive side of the bus, ran it to the switching board. There's a resistor in there, and then through the switch, out through the switch, back to the positive side of the LED, out of the negative side of the LED and into the negative side of the 12 volt bus. So kept it very simple. So I hope this actually inspires and creates ideas for people. It's a really cheap and easy way to create a kind of model fire effect. So I hope you enjoyed it, and thanks for watching.